Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over question number 5 of the 2018 AP Calculus free response question, focusing on differential equations. Question number 5 reads, during a chemical reaction, the function y equals f of t models the amount of a substance present in grams at time t seconds. At the start of the reaction, t equals 0, there are 10 grams of the substance present. The function y equals f of t satisfies the differential equation dy dt equals negative 0.02 y squared. So the A part, assessing on how to carry out timeline or linear approximation, reads, use the line tangent to the graph of y equals f of t at t equals 0 to approximate the amount of substance remaining at time t equals 2 seconds. Okay, so before we get started with the problem, let's go ahead and write down the formula that's going to guide our problem solving process. Okay, so we're going to be using the tan line formula and also the linear approximation formula. So let's start with the tan line. How do you write or how do you find the equation of the tangent line to a graph at a point? Well, you use the formula y minus y1 equals m times x minus x1. Okay, this is a algebra 1 formula. You just need a point and a slope. But since it's a tangent line, in this case, we do not have the luxury of using rise over run or y2 minus y y2 minus y1 over x2 minus x1 to find m. So in this particular formula, m is basically the derivative at the specified point. So m is y prime of a. Okay? All right, so we have algebra with a hint of calculus. That's how you do it. Now let's go ahead and determine how do we approximate. If you want to approximate y at a, y at the point A is basically what you get when you isolate y in this formula and you plug in a for x. So y of a is approximately m times x minus x1 plus y1. Okay? All right, so let's be more specific here, because in this particular formula, we need to evaluate it when x is equal to a. So we're just gonna, let's put a line here so we show what's going on. So this evaluated at x equals a. Okay? All right, so let's go ahead and apply this formula to this particular problem. All right, so our solutions is as follows. Let's go ahead and list all the things we know and what we need to find first, and then we'll go from there. We need a point x1, y1. So x1 is basically the t value here. So we know that we're dealing with y is equal to f of t. Okay, so you think about y equals f of t. It's just like y equals f of x. So our t is basically our x in this particular problem. So x1 is the same thing as t1, which is the starting time of 0. And then our y1 is basically the function evaluated at that particular t1 value, which is y of 0, and we're told that at time t equals 2 seconds, not 2. At time t equals 0 seconds. What does it tell us? At times t equals 0 seconds, there are 10 grams. Excellent. So we have y sub 0 is 10. Okay. And now we'll in the second part of part A, we're looking for the amount of the substance at times t equals 2. So that's our A value. That is what we're estimating. Okay, so A is equal to 2. We're going to use this at the end. And then we need M. M is basically going to be our derivative at t equals 0. So let's go ahead and carry out that calculation. I'm going to do it over here. So to find M, Our m is simply y prime of 0. Okay, so we are still using t1. We don't use this a until we get to the end. Okay, all right. So in order to find y prime of 0, we need to first of all find y prime. And then after we find y prime, we evaluate it at the specified time t1 value, which is 0. Okay. So what is y prime? Well, we are already given y prime. Y prime is the same thing as dy dt, and that's a given in this problem. The y dt is negative 0.02 y squared. Now this is a weird differential equation because it's dependent on the dependent variable, not the independent variable. Okay, so check this out. In this particular case, y prime at 0 is the same thing as dy dt evaluated at the ordered pair 0, 10. So this is, what am I going to plug in here? I'm going to plug in not t, but I'm going to plug in y. All right, so we'll plug in 10 square like that, and that's how we'll calculate the slope. Okay, if we do our order of operations here, we can just simply calculate what that is. So y prime of 0 is going to be negative 0.02 times 100. And then 100 is just going to move the decimal point to the right 2 places to give us negative 2. Okay? All right, so there goes m. So we now know what m is. M is negative 2. So we're going to put everything together and use that to write down the equation of the tangent line. All right, so m equals negative 2. So let's write down the equation again so we don't get confused. Y minus y1 equals m x minus x1. So we have y minus y1 is 10 equals m, we just found it, negative 2x minus x1, what is x1? 0. Okay, and then we have y. Let's put in slope intercept form. Okay, so we have y equals negative 2x, and then add 10 to both sides plus 10. Okay, so these two are the equation of the tangent line. This is in let's just write it down. This is the equation of the tangent line in point slope form. And then this is the equation of the tangent line in slope intercept form. All right, so why did we go through the work of putting the equation of the tangent line? Let's write it out. Equation of tangent line. Why did we go through the work of putting it in slope intercept form? Well, it's easier to figure out, to use it to estimate. Okay, this is y of t. Okay, all right, so let's even rewrite it. Since the independent variable is t, we can just rewrite it as y equals negative 2t plus 10. Now, if we want to estimate, for example, we want to estimate the function at t equals 2, we just simply plug the 2 in here. All right, so y of 2 is approximately what you get when you evaluate this expression at t equals 2. So it's going to be negative 2 times 2 plus 10. That's why you put it in slope intercept form. Okay, so it's easy to calculate. Using our order of operations, that's going to be negative 4 plus 10, which is equal to 6 grams. All right, so that's the estimated amount at times t equals 2 using the tan line approximation. All right, let's look at the B part. It says using the differential equation, determine whether the graph of f could resemble the following graph. Give the reason for your answer. Okay, so we know that in the problem we're given the function y is equal to f of t, and we had the differential equation. This equation satisfies the differential equation dy dt equals negative 0.02y squared. Okay, so if this is a differential equation, can this graph represent a particular solution? That's what the question is asking. All right, so first of all, let's talk about what the connection is between the derivative of a function and the graph of the function. Okay, so what's the connection there? Let's go ahead and write it down. So the formula is as follows. We're gonna use the fun chart to help us out here. Okay, so f concave up, concave down, f prime. We're looking at f and f prime. Okay, so if a function is increasing, the derivative is going to be positive. If the function is decreasing, the derivative will be negative. Okay, so let's call this graph right here g, function g. The question is g equal to f? Could it possibly be this a particular solution to this differential equation right here? Could it? All right, so let's write this out. What this is telling us, if the derivative, if f prime of x is less than 0 or negative, then f is going to be decreasing on that interval. Okay, and then if f prime of x is positive on that interval, then f is going to be increasing on that interval. Alrighty, so here we have a situation where the function g is decreasing. Okay, it decreases and then after it starts to increase. So could this possibly a function that satisfies this differential equation? All right, let's see. So let's start by taking a look at the differential equation, or f prime, and then see if g is behaving in such a way that it could be f. So what do we know about f prime? So f prime, which is equal to dy dt, is equal to negative 0.02y squared. Okay, so if you study this function closely, what does that tell you about the sign of f prime? Because the sign of f prime tells you how f behaves. Okay, so what you notice is that it's dependent on the square of y. All right. So what do we know about all numbers squared? If you square every number, you always end up with a positive number. Okay, so since y is squared, what does that tell us about the sign of f prime or dy dt? Since y is squared, f prime, which is equal to dy dt, is always going to be negative. Okay, it's always negative because of this minus here, and this is positive. It's always going to be negative. Alrighty, so if the derivative is always negative, what does that tell you about the function, the behavior of the function itself? If the derivative of function is always negative, that means that the function is always decreasing. Okay, so let's go ahead and write that down. Since the derivative, since f prime, which is equal to dy dt, is always less than 0, the graph of f is always decreasing. All right, now let's look at this graph that we're given here. We called it g. Can this graph be f? Absolutely not. Why not? Well, because it's not just strictly decreasing. It decreases first on this interval, and then what does it do after that? It starts to increase. Okay, so this guy right here cannot be the graph of f because the behavior changes, whereas f, the behavior doesn't change. It just keeps decreasing on the entire interval. So let's go ahead and write down our conclusion. The given graph cannot, okay, It cannot be the graph of f. Why? Because the given graph is not always decreasing on its domain, unlike f, which is always decreasing. All right. So the graph of f, if you want to look at the graph of f, it will be something like this. Something that keeps going down and down and down forever, okay? But if the behavior changes, that shows that the first derivative is going to be positive and it doesn't satisfy the differential equation, negative 0.02 y squared, all right? So there goes the answer for part B. All right, let's take a look at question 5C. This one involves how to solve, you're being assessed on how to solve differential equations. We're going to be using the method of separation of variables, alrighty? So let's write down the procedure that we're going to employ in solving this differential equation. Let's read it first. It reads, find an expression y equals f of t for solving the differential equation dy dt equals negative 0.02 y squared with the initial condition f of 0 equals 10. All right, so we're going to use the sci-fi I procedure to do this. So separation of variables, we'll start first by separating the variables. We're going to separate so we're going to have the y's on the left side and the t's on the right, okay? So we're going to separate the variables. And then we're going to integrate. And then we're going to find c. And then we're going to insert c into the equation that we integrated, and then we're going to go ahead and isolate y, all right, in the equation where c was inserted. So when you get your y isolated, ladies and gentlemen, you have achieved the solved state of your differential equation. Okay, so that's what it means by the particular solution where you have y isolated. All right, let's go ahead and get started with the process of solving this differential equation using the method of separation of variables. So starting with part 1, we're going to separate the variables. All right, so what are we separating? We're going to have, well, we have f of y and f of t, okay? So we're going to have f of y and the y on the right, sorry, on the left, and f of t and the t on the right. All right, so you always put the dependent variable and its differential on the left, and then the independent variable and its differential on the right side. So we have the differential equation dy dt equals negative 0.02 y squared. So we need this dt, this differential here, to the right side. So we'll multiply both sides by dt. Okay, so that will achieve this to divide out. We have dy equals negative 0.02 y squared dt. And then we need this y square. We can also take get that negative away to the left side. So let's get y square and negative to the left side. It doesn't really matter where it's at, but let's just move it. So to move the y to the right side, to the left side, we multiply both sides by negative 1 over y squared. This is equivalent to dividing by negative y squared. Same thing, okay? All right, so we do that. And then you notice on the right side, this minus and the y squares disappear, divide out. So we have the separated equation, negative 1 over y squared dy. So this is f of y dy equals, negative is gone, 0.02 dt. So this is f of t dt. So we have separated the variables. Excellent. So let's move on to the next part. Part 2 in sci-fi I is to integrate both sides. Okay, so we're going to integrate. When we integrate, guess what? We're gonna get rid of the dy and dt. Okay, so let's do it. So we're gonna integrate the left and right sides of the equation. So we're integrating one color. Let's do that again. We're gonna integrate negative 1 over y squared dy, and then we're gonna integrate 0.02 dt. Okay, so in this particular case here, how do we integrate negative 1 over y squared? Well, let's factor out the minus, and then there's no rule for 1 over x squared for integrating, so we have to rewrite this as a power so we can apply the power rule nicely. Using the reciprocal property of exponents, we rewrite that. I like to integrate both sides of my differential equation at the same time. So it's a good practice that can help you avoid making mistakes associated with multiple integration steps. Okay. All right. So now I'm ready to integrate both sides at once. So using the power rule on the left side, if we integrate that, we're going to have y to the power plus 1, which is negative 1, divided by the power plus 1, which is negative 1, plus c. And then on this side right here, if we integrate with respect to t, is 0.02 t. Okay. Now this c right here is a composite. C is a combination of the c from the right and the left. Just put them together here on the right. Okay. All right. So we have 1 over y using the reciprocal property of exponents, and then these two minuses slash and dash to become positive, equals 0.02 t plus c. Okay, this is known as the general implicit solution of our differential equation. What we're looking for is the particular explicit solution. We're going to advance to step 3, which is to find c. Okay, to find c, how are we going to do that? In order to find c, let's go ahead and put it down. Step 3, to find c, we're going to be using the information, the initial condition given to us, f of 0 equals 10. What does that mean? What does f of 0 equals 10 tell us? Well, it tells us that we're looking for the particular solution that goes through the ordered pair 0, 10. So in this particular problem, the independent variable is t and the dependent variable is y. Okay, so we're going to substitute 0 for t and what? 10 for y. All right, and then we're going to, that will enable us to solve for c. Let's do it. So we have, let me rewrite the explicit, not explicit, the implicit general solution. 1 over y equals 0.02 t plus c. So plug in 10 for y, and we're going to plug in 0 for t plus c. Okay. All right, so there you have it. So let's go ahead and solve this for c. We're just going to have, oh, this is easy to solve. 1 over 10, let's write it as decimal, okay? 0.1 is equal to c, so that's what c is. All right, so we found c. Now, what we're going to do is we're going to insert c and isolate y in the equation that c is inserted into. So that's the last one. To finish this off, step 4. So you're going to insert c, where we're going to insert c into what we got in step 2, which is this general explicit solution here, general implicit solution. Insert c into 2 and isolate y. Remember to isolate y, okay? Insert c into 2 and isolate y. All right, so let's carry out the insertion. We're going to have 1 over y equals 0.02 t plus c, which is 0.1. Okay, now this is known as the general, it's the particular implicit solution. So we need to make it explicit. To make this explicit, we need to get y isolated. That's the isolation y step that we're talking about here. Okay, so to make that happen, it's not that crazy. We just express the right side as a fraction. Okay, and then just reciprocate both sides of the equation. So we just reciprocate this side and reciprocate that side right here. What I'm doing is just flipping the entire equation, okay? So we're going to have y equals 1 over 0.02t plus 0.1, okay? So this is exactly what we are looking for. This guy right here is called the explicit particular solution of our differential equation. And this guy over here is called the general implicit solution. Okay, and then this one that we reciprocated is the implicit particular solution. As soon as you plug in c, it becomes particular because you're looking at a particular point. All right, let's look at the last part. It says determine whether the amount of substance is changing at an increasing or decreasing rate. Explain your reasoning. Okay. All right, so this question is kind of worded in an interesting way. What you can do is, let's rephrase what the question is asking. Okay, so when asked to determine whether the amount of substance is changing at an increasing or decreasing rate, think about this changing as the rate of change. So the question is asking, is the rate of change of the amount increasing or decreasing? All right, okay, so let's rephrase it so that we understand what another question is asking, because the way it's written there is weird. So rephrase, the question is asking, is the rate of change, or the rate of change of the amount, which is y, increasing or decreasing? That's what it's asking. What is another word for rate of change? Another word for rate of change is the derivative. So those questions basically asking, is y prime positive or negative? That's basically what it's asking. Okay, so what you need to recall is the following. If you're asked if a function is increasing or decreasing, you need to look at the sign of its derivative. Okay, so the behavior of the rate of change of y can be determined by simply looking at the sign of its derivative, sign of y prime. Okay, all right, so it says behavior rate of change of y, look at the sign of sign of a y double prime, not y prime. All right, let me write it this way. So you look at the sign of the derivative of the rate of change. So the sign of rate of change of y prime. So what's the sign of the rate of change? That's what it is. What is the sign of the derivative of the rate of change? So the sign of the derivative of the rate of change is the same thing as the sign of y prime is the rate of change prime, y double prime. Alrighty, so that's what we're looking at. We're looking at the sign of the second derivative. All right, so let's give ourselves a visual as to how this works. So let's put up a Young chart real quick. So concave up, concave down, y prime increasing, decreasing, y double prime, positive, negative. Okay, so we're looking at where is the sign of the rate of change, the derivative of the rate of change, positive or negative, okay? Or basically we're looking at the behavior of the rate of change. So this is the rate of change right here. This is ROC, rate of change. Okay, so is the rate of change increasing or decreasing? In order to know if the rate of change is increasing or decreasing, what do you look at? You look at the derivative of the rate of change, also known as the second derivative, and you ask yourself, is it positive or negative? That's all we're doing. Okay? All right, so we're just looking for the sign of y double prime. Let's do it. So we have y prime is given to us. dy dt is negative 0.02 y squared. Okay, so let's differentiate that. We can even write it as dy dt, doesn't really matter. In the question, it was written as dy dt equal negative 0.02 y squared. So let's differentiate that. So the derivative of this, d squared y dt squared, is going to be negative 0.02. Now we're differentiating with respect to t. So what does that mean? If you differentiate y squared, you're going to have 2y, right? Is that all? No way. If you're differentiating, you have to check for agreement, okay? This is implicit differentiation because y, this equation is not solved explicitly for y. You have y and dy dt all over the place. So since we're differentiating with respect to t, there's a disagreement here. So when you differentiate this, you have to add on what? dy dt. Alrighty, so when differentiating, implicitly do not forget that component. And then when you're done differentiating, finding the second derivative, check this out. There is another important step you do not want to forget, and that step is to substitute out something. So 0.4y dy dt. There's something that we need to substitute out. Do you know what that is? Is very important not to forget. Well, we know exactly what dy dt is. So we can take what dy dt is right here and just plug it into the spot right over here. Okay, so the second derivative, or the derivative of the rate of change, d squared y dt squared, is equal to 0.04y, don't forget the negative, times negative 0.02y squared. Multiply that together. What you're going to have, well, 2 times 4 is 8, and it's positive, and we have 1, 2, 3, 4 places behind the decimal point, so 0.000. So that's 1, 2, 3, the fourth place is 8, y to the third. Okay, so this is the derivative of the rate of change. All right, so what is the sign of the derivative of the rate of change? That's what we're looking for, right? The sign of the derivative of the rate of change will tell us the behavior of the rate of change, how fast, how the amount is changing. Is it increasing or decreasing? So what do we notice if you take a look at this equation that we have right here? Now, what do we know about y? Y is the amount, okay? So y represents the amount. So what does that mean? If y is an amount, is there any such thing as negative amount? Is it possible? We're looking at the amount of a substance. If y represents the amount of a substance, then we know for a certainty that y has to be greater than 0. All right, so that's very important information, okay? Because if y is positive, what does that tell us about this expression right here? if y is greater than 0, then the derivative of the rate of change, or the second derivative, let's write it as the derivative of the rate of change, is going to be what? If y to the third is positive and you multiply two positive numbers, what do you get? You end up with a positive, right? So if y is positive, then the second derivative, or the derivative of the rate of change, is also greater than 0. All right? If the sign of the derivative of the rate of change is positive, then that tells us that the rate of change is doing what? Let's look back at our chart. If the sign of the derivative of the rate of change, or y double prime, is positive, that means that the rate of change, dy dt, is increasing. Okay? So the amount of substance is changing at an increasing rate. That's the answer right there. Okay? All right, so if y prime is positive, then the derivative, the sign of the rate of change, is positive, and that tells us that the amount of substance is changing. So the amount of substance is changing basically represents the rate of change of the amount, okay? The amount of substance is changing at an increasing rate. This is the sign of the derivative of the rate of change, okay? So there goes the answer to question number 5D. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calc exam, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel. We upload math tutorials to our page on a regular basis, so just subscribe to get updates concerning our uploads. If you have any questions or comments about the AP Calc exam in general, just put it in the comment section below, and we'll be more than glad to support you. Don't forget to visit our website at mathgotserved.com for tons of resources to help you prep for the exam. Thanks again for watching, and have a wonderful day.